welcome to Utkarsh Minds Python for Data Science. Collab we will start because we want to see in Seaborn how we can work with Python. In a new notebook, we will write our Python programs. So the first, this is lesson 26, Seaborn and Regression Plots. I will click connect. First is to import my data set. So I will import Seaborn, and using Seaborn I will load the data set tips. This data set has 244 rows and 7 columns. So first is to understand the relationship between two numeric variables. So numeric means scale or quantitative, or just in simple words, numbers. So when the data has only numbers, in this case, how will we understand relationship between the two columns? So for that there is a simple way, Seaborn regression plot or Seaborn REG plot. In this we will first have total bill on x-axis, tip on y-axis, and then the data which is tips. So you can write here data which is the tips data frame. The regression plot will look something like this. On x-axis there is total bill and y-axis there is tip, plus there is a regression line. This is giving the relationship that when total bill increases, your tip value also increases. If it had been downward slope, then as total bill increases, the tip will be decreasing. Along with the regression plot, there you can see some standard deviation or standard error. So in statistics, mean and standard error, standard deviation, these important concepts are there. You are seeing the average or the mean, and the line is the deviation or the standard deviation. Along with that, this can also have one more plot is there in Seaborn, the LM plot. It is also doing the same thing. You have to give data frame which is tips, you have to give size, and on Y you have to give tip. With this you should get a similar linear plot which gives the relationship between size and tip. So in general, size increases and of tip also increases. Size means the number of customers that come. So if there are 6 people in a family who are coming to eat, they will give a bigger tip than a one person family. Along with there is some other possibilities as well which are not so useful, but one which is useful we will show you here. We will just copy this LM plot and add one extra argument in LM plot, that is the X estimator. So X estimator, and in this X estimator we will write numpy dot mean, and here I will import the numpy function. So we are taking the average of the different data points on the x-axis, which is the size, and we are giving the mean and standard deviation of those points, and we are showing the regression fit. So these are some useful points which can be done, which can be achieved with the help of LM plot and regression plot. However, there are multiple more things we can. Usually a linear plot is sufficient, but not always. There may be some non-linear relationships in the data. So for that, we can have the variable anscombe. In this anscombe, what we can do is we can find out that there is a data set. Let us have data set anscombe. In anscombe, on x axis there is the column x, on y axis we have the column y, and then there is the data. So in this data you can write anscombe data set, and let us see how is the regression plot. So it is something like this. But if you feel that this regression plot is not sufficient, then or the data or the relationship is not linear in the data, then you can modify the linear regression plot. So I will write like this. I am using a data set where I have I say let me use this anscombe query data set second. So there are some multiple data sets in this, and I am using the data set numbered second. Linear regression plot will not work because there is a non-linear relationship, but what I can do is I can write here order equals 2, and that gives me a better fit of the data. So I will leave both of these options for you to explore, one without this order argument and one with the order argument. Suppose there are outliers in data. So let us say there are outliers. For example, here you can see that there is one anomalous or abnormal behavior here. So this is the outlier. So in this case, what you can do, the simple linear plot will not work. Here you can write robust equal to true. This will give a better fit of your data. And see, you are getting a much better fit of the data than the previous plot. If your y is not numeric, here y is numeric, but let us say y is not numeric. So let us go here, and smoker. Smoker is an attribute that is not numeric. It has only two values, yes and no. So it is binary variable. Binary, which means that it can take only two states. So the smoker variable is binary. It has yes or no. So in this case, your LM plot will fail. So let us see what happens. LM plot where x is the total bill, and let us say y is smoker, and your data is tips. So could not convert string to float because it is a non-binary data. In this case, let us convert from string to float. So let us have smoker binary, and I am converting my tips by replacing in this column smoker, we will replace yes with 1 and no with 0. So here we will then replace this smoker binary column here, and can't multiply sequence of non-int, there is a error. The error comes because you are using a binary variable and linear LM plot requires the y to be a numeric variable. So in that case, there is one addition you can do is add here logistic equal to true, and I will take this in a new line. Okay, I made a mistake here. Now I have corrected that. In this line there were some double quotes around 1 which have to be removed. So that is now removed. You are getting here tips as binary, and then when you run this, you should get a separation between smokers and non-smokers. So there is a separation between the smokers and non-smokers. It looks like this. So that is the use when y is a binary variable and x is numeric, or x may also be binary. That is the advantage of this regression plots, and we will see more such plots for finding the relationship in the next video. Thank you.